Hello, it's Bill again. And I'm going to redo this video for entanglement, and this is going to be the part 2 update and correction. I found some information that I wanted to share with you so we can continue on. So first we're going to do a review of definitions. A cosmic event horizon, the maximum boundary for any given host particle consisting of a spherical horizon that behaves much like an inverted universe-sized black hole, relative only to the host. Its geometry is defined by the number of all previous distant particle crossings adding Planck areas of gravitational energy, growing that horizon to present-day sizes. Cosmic horizon causes the emergence of dark energy, which accelerates objects out of a given host particle's observable universe. Cosmic event horizons are the engines that process information and redistribute entropy from local to cosmic scales. The host particle, a fundamental particle at the center of its own cosmic horizon, which defines the limits of its observable universe. This expression is the first 360 degrees of spin in the 120 degrees of spin for matter particles. A host particle cannot cross its own horizon, although the horizon size dynamically evolves. A host particle has a universe worth of information associated with it, 10 to the 122 degrees of freedom in the form of horizon Planck areas, Hawking photons, and other guest particles. Guest particle. Any particle within a host particle's observable universe that is not the host itself. Guest particles interact dynamically with host horizons and can appear to exit the host universe via cosmic horizon redshifting. Guest particles have 1 degree of freedom and are the second rotation of 720 degrees of spin, the distributed portion of a matter particle's spin, so that every matter particle is encoded on every other matter particle's cosmic horizon. Entanglement. Entanglement occurs when two matter particles in spin superposition interact, establishing a quantum link that forces their spin states into a correlated, discrete up-down values. Entanglement causes an energy relationship between the host and guest, which allows for the instant correlation of spin information via spooky action at a distance. So here we have kind of the geometry of host and guest. So we have host A here, and its first rotation is projected at the very center of its horizon. It's always at rest in its own reference frame because it's projected equally from all angles. And now host A has 3 guests, and these 3 guests spin also project the second rotation of host D, of host B, and host C are projected from A's horizon. And this second rotation is temporally offset by the light delay distance between each one of these particles. So for guest spin purple, it's going to have this temporal delay on its second rotation. Host D's first rotation is its current evolving now, but in A's universe, host D's second rotation is actually temporally offset as a quantum object in A's observable universe. So A's host spin information includes 10 to the 122 Planck areas of resolving power. B's guest information and 1 bit, 1 Planck area. C's guest information, 1 bit, 1 Planck area. D, 1 bit, 1 Planck area. So the host has all of this information associated with it. Each one of these particles is just 1 bit. So we're going to talk about entanglement, stage 0. The particles are in superposition, no association energy present yet, meaning no entanglement. Host and B are matter particles, each in a superposition of spin states. No entanglement energy is present to associate the two particles. They exist independently with no active interaction. Now here we have host A, and it has its spin projecting at all angles holographically, and that's why we have several different labels. It's all the same information, but it's holographically spread out. And then guest B is also holographic information in host A's universe. Similarly, in B, we have host B information that projects host B's current now. And then we have also the holographic guest A, which is temporally offset by this distance of A's second rotation of spin in B's universe. Host A and all guest particles are not yet addressed. They exist holographically smeared across the entire cosmic horizon of both host particles' cosmic horizons as unassociated information. Entanglement, stage 1, 2-bit addressing across cosmic horizons. Host A and host B interact and now share an entanglement boson on each of their cosmic holographic horizons. This boson associates the host and guest particle information across both horizons as a 2-bit system. Now notice how each cosmic holographic horizon now contains both host and guest information addressed as 2 bits. These are holographic expressions of the same particle, host A with guest B and host B with guest A, distributed across the entire horizon. Each host contributes 1 bit, forming a total of 2 bits per entangled pair. So here in A's universe, we have guest B and host A. That's 2 bits. Now this is holographic, so it's the same 2 bits. It's just holographically spread out. Over in B's universe, we have host B and guest A is 2 bits assigned. A and B are each waiting to see who gets measured first, because whoever gets measured first gets to handle the spin resolution and the entropy management. Okay, stage 2, spin collapse and quantum to classical conversion begins. Host A and B are entangled. Particle C arrives and collapses A's spin. The first particle measured of the entangled pair is the one whose cosmic holographic horizon will resolve the spin and manage the associated entropy cost. The odds for up or down are 50-50. Now here we see when C interacts, now A can have a spin. The spin sign will randomly appear, spin up or spin down. And what happens here is because that happens, now A's horizon actually is going to hand the information from host A to guest B. It's going to transfer that information so guest B can carry host A's spin. Host A translates spin to guest B by Planck area erasure, putting host A and guest B's quantum state at the same coordinate, so guest B now reflects the same spin sign as A via their shared horizon address. So this is the shared horizon address here. Stage 3, the classical bit emerges gravity emitted. Host A translated its spin to guest B. Now that A is no longer entangled with B, the quantum uncertainty of 2 bits becomes 1 classical bit. Guest B will reflect the same spin energy sign as A. This erasure is an act of entropy. The mechanism for translating spin to guest B was host A's erasure of 1 Planck area of its cosmic horizon. Guest B becomes spin locked, so when B is measured, B will show the opposite sign of A. This erasure breaks A's entanglement and causes gravity to emerge from the horizon, appearing as a gravitational effect at A's location in 3D space, and as a local expression of the universe getting 1 unit of information smaller. So when A was measured, it erased that bit and put the information into guest B. And that erasure of this energy, of this quantum Planck area, snaps back to A. As A was entangled with the horizon, A still exists, but that horizon bit no longer does. So it snaps back out to A as gravitational energy. And then B is still spin locked here. This is the second rotation of B that's going to be temporally offset from its host. So B's past already has the spin information. B is just waiting to be measured to update its spin into its present. Stage 4, closing the books with the Hawking photon emission. Guest B locks spin into host B when host B interacts with a new entangled pair, DE. It collapses that pair's spin, continuing the cycle. This interaction triggers the Hawking photon emission from host A, completing the energy ledger. Guest B's constraint acts like a capacitor, releasing the leftover information as a spin-locked Hawking boson. So even though the interaction at host B happened and the spin sign emerged, actually it was guest B in A's universe that actually held the spin sign. So once it refreshes guest B's information to host B, it emits this energy, this leftover entanglement energy, as a Hawking photon. When host B interacts with entangled pair DE, guest B potentiates the Hawking photon by drawing a tiny portion of interaction energy from interacting with D. This energy is emitted into host A's observable universe as a photon, conserving energy and entropy. And here's a spin equation right here about what happened here. We have S plus, which is the subordinate spin, E minus, this is the Planck area erasure for A, and then S minus is the subordinate spin. So whatever S plus was, S minus must be the opposite after measurement. E plus is the Hawking photon emission when B is measured. And you can see the entropy conserves. We have plus S, minus S conserve, and we have negative energy from the Planck area erasure, and we have the positive energy from the Hawking photon emission. Those also conserve perfectly and meet zero. Entanglement stage 0, return to superposition. The cycle is complete. Host A and host B are both back in superposition and ready to entangle again with each other or new particles. All information has been fully expressed and translated. The total cost of the cycle, 1 unit of cosmic horizon gravity via Planck area erasure, and 1 unit of Hawking information. Host A and all guest particles are again unaddressed. They exist smeared across the entire cosmic horizon of both hosts as unassociated information. The universe now slightly smaller from the reduction in entropy from collapsing 2 quantum uncertain bits into 1 classical bit of information. So the cosmic horizon just shrunk 1 Planck area, and now that cosmic horizon is projecting a little bit different geometry of space. And that geometry of space-time it's projecting is actually the Hilbert space. So this cosmic horizon projects Hilbert space as space. And anytime this horizon changes in size, it's going to affect whatever A can do in its observable universe. That's it for today. Thanks for joining us to discover how entanglement causes gravity. Be sure to watch my YouTube channel, Gravity for the Masses. Come discover gravity with Max and Me playlist. Keep thinking and keep exploring.